Hello, ladies and gentlemen. This is Asaz Amjali in front of you. Today, we're going to be looking at directional derivatives. We're going to be practicing more on directional derivatives. So, on directional derivatives, there are certain parts or things that you need to consider while doing directional derivatives. Firstly, at the unit vector, because in directional derivative, it's the gradient of the function multiplied by the unit vector, which is the gradient of the function as a whole multiply it by the unit vector. So it's the directional vector gradient of the function multiply it by the unit vector. So firstly, Mina, I'd like to start by the unit vector. How do we calculate the unit vector? Now, so how do we calculate the unit vector? Unit vector at u it's equals to 1 over the magnitude of the unit vector multiplied by that unit vector. So here we are given the vector, and then this is the vector that we can use to calculate our unit vector. So here we go, let us calculate our unit vector. This is going to be u for unit vector is equals to 1 over the magnitude of the unit vector is going to be 2 square root 3 all squared plus 2 all squared multiplied by the unit vector, which is 2 square root 3 I plus 2j. And then here we can bring this on the numerator, because 1 multiplied by a certain number is that number. So u is going to be um, 2 root 3 I plus 2j over, so let us fix whatever it is under the square root on our denominator. So we know that the square root will cancel with the 2, and then the 2 multiplied by the 2, this is going to give us 4 multiplied by 3, and then plus what is 2 exponent 2, this is going to be 4. So simplifying our denominator, we're still going to have 2 square root 3 I, this is I, this is I, plus 2j all over what is 4 times 3, this is going to be 12, plus 4, this is going to be 16, right? Yes. And then the square root of 16 is 4. So this is our unit vector. What do we do with the unit vector? We say for the directional derivative, we take the gradient of the whole function multiplied by the unit vector. And then here we go. We already have one thing to solve our problem. So let us move forward and find the gradient of the function. So our function is x cubed minus 2x squared plus y cubed. Our function is x cubed, right? Yes, x cubed minus 2x squared plus y cubed. So our next step here is to find the directional derivative, not the directional derivative, but the partial derivatives in terms of x and in terms of y. So firstly, let's find the directional derivative in terms of x. So looking here, we have x on our first term, x on our second term, and there's no x here. So what is the derivative of x cubed? This is going to be 3x squared. What is the derivative of 2x squared? This is going to be minus 4. Now take note, here we don't have any x that has to do with our third term. So this term here, we're going to take it as a constant. And the derivative of a constant is always 0. So we're going to be left with something like this for our partial derivative in terms of x. And then moving forward, we're going to take the partial derivative of the function in terms of y. So looking at our function, we have nothing we don't have y here, we don't have y here, but we do have y here. What does it mean if we don't have y? Sitting at these two terms, we're going to take this as 0 because the derivative of a constant, this is going to be a constant, and then the derivative of a constant is always equals to 0. So these two is equals to 0, but only if we are taking a partial derivative in terms of y. So our partial derivative here is going to be 3y squared. So moving forward, we find the partial derivative of a function in terms of y. And then previously on our statement, we're given that we have a point. We have a point P, which is 1 is to 2. So what do we do with that point? Now we have to simply substitute the point on our partial derivatives. So substituting here, but we said P is 1 is to 2. So this is our x and this is our y. So substituting here, it's going to be 3 and 1 squared minus 4, 1. Just going to be 3, 1 exponent 1 is 1, then 3 multiplied by 1 is 3, minus 4 multiplied by 1 is 1. It's 4. So this is going to be negative 1. Negative 1. Negative 1, right? This is negative 1. Mind you, this has to do with the direction. It always has a direction. So it's more like this is going to be negative I. And then substitute it here, substituting our y variable here. So this is going to be 3 into 2 exponent 2. This has j for the direction. So 2 exponent 2 is 4, and then 3 times 4 is 12. J, don't forget about the directions. Then now we said our directional derivative is the sum, it's our gradient multiplied by the unit vector, and then the gradient is the sum of our partial derivatives multiplied by the gradient. Let us take the sum of our partial derivative. So our gradient here is going to be equals to negative 1 plus 12j, negative I, plus 12j. And then what's next from here? We take our gradient, multiply it by the unit vector. So look at our unit vector is 2 root 3 I plus 2j all over 4. Vector, this is our unit vector, and then we're moving forward to find our directional derivative. So it's going to be negative I plus 2j multiplied by our unit vector, which is 2 square root 3 I square root 3 square root 3I plus 2j over 4. All over 4. So let us now multiply this all out. So we are multiplying the corresponding values. We're having I here, and then we're having I here. 2 root 3 I over 4 multiplied by negative I. So this is going to be negative 2 root 3 over 4. And I multiplied by I at 1, and then y, 1 doesn't affect anything here. Then plus 2 multiplied by 12, this is going to be 24. And then we can add this and get our final answer. Thank you very much.